Hey guys, welcome back. My name is Miss Danielson and I'm taking you through a short lesson on rounding to decimal places today. I hope you joined us for our previous lessons on place value and rounding to place value. If not, I'm linking them down in the description box below so you can go check those out. Otherwise, let's get started with our lesson, our examples, and as always, we'll finish up with an exercise and answers taken up at the end. Let's get started. First of all, our learning objectives for today are to be able to identify the number of decimal places in a number, to be able to round to a whole number or a set number of decimal places, to understand the inaccuracy or the rounding error caused by rounding, and to recognize that rounding to different degrees of accuracy can produce different values. First of all, to be able to do this, what is a decimal place? Each digit to the right of the decimal point is considered a decimal place. The digits to the right of the decimal point, those are the fractional values. So that's the fractional part of the number. And each of those digits, regardless of the digit value, has a value between 0 and 1, whether it's some number of tenths, hundredths, or thousandths, or so on. The place values to the right of the decimal point always have place value names ending with th, because that th means that it is some fraction. In the tenths position, for example, we would write that digit as a fraction over 10. In the hundredths position, for example, we would be writing that digit value as a fraction over 100. The further the digit is to the right of the decimal point, the smaller the value it holds, because the denominator of the fraction grows bigger and bigger as we move to the right. Tenths, hundredths, thousandths, tens of thousands, and so on. This number, for example, 4.0362, has 4 decimal places. We can round this value to any number of decimal places between 4 and 0. However, if I were to round this number to 4 decimal places, I wouldn't have to do very much because it's already got 4 decimal places. If I wanted to round it to 0 decimal places, I would be rounding it to a whole number. Let's go through a few examples. So here you've got 5 numbers, and I want you to round each of these numbers in 4 different ways. To 3 decimal places, to 2 decimal places, to 1 decimal place, and to the nearest whole number, which is no decimal places. Starting with this first one here, 4.3875. There are 4 digits after the decimal. So this number has 4 decimal places right now. If I want to round it to 3 decimal places, I'll look at the number or the digit that is in the 3rd decimal place. That's this 7 here because it's 1, 2, 3 places to the right of the decimal, and that 7 has a 5 after it. If that number is 5 or higher, remember we round up. So that's going to round to 4.388 to 3 decimal places. That's the same thing as 4 and 388 thousandths. So when we round to 3 decimal places, we're really rounding to the thousandths position. Next, let's round this number to 2 decimal places. So going back to the original number here, 4.3875, that's a long number. It's got 4 decimal places to it. I want to round it to 2 decimal places. So 2 digits after the decimal, that would be where the 8 is, and the 8 has a 7 after it. 7 is definitely bigger than 5, so the 8 is going to round up. That will give us 4.39, or 4 and 39 hundredths. When we round to 2 decimal places, what we're actually doing is rounding to the hundredths position. See, telling you how many decimal places to round to makes it a lot easier for you because you don't have to remember the names of the place values. Next, let's round to 1 decimal place. What do we call that 1 digit after the decimal place? That's the tenths position. So rounding to 1 decimal place means round this number to the nearest tenth. And a 3 in the tenths position with an 8 after it will round up. So that will be 4.4, or 4 and 4 tenths. Finally, to the nearest whole number, A whole number has no numbers after the decimal point, so that's rounding to the units position. That's just going to be 4 with a 3 after it. Does not round up. That will stay 4. Let's go a bit quicker now. So B, rounding to 3 decimal places, that 2 with an 8 after it rounds up to a 3. So 1.403. Next, to 2 decimal places, the second decimal place is a 0. A 0 with a 2 after it is going to stay the same. So 1.40. Notice that I am writing this 0 here. Usually when we round and we have zeros after the decimal point, we don't write them down. But here we need to because we're told to round to 2 decimal places. So I want to make it really clear my 2 decimal places are 4 and 0. I didn't accidentally round just to 1 decimal place. There is a 0 in the hundredths position. To 1 decimal place, that's to where the 4 is. With a 0 after it, it's going to stay a 4, 1.4. Note that these two values are the same. However, here I'm not going to put a 0 in the second decimal place because I want my answer to only have 1 decimal place. Next to the nearest whole number, a 1 with a 4 after it will stay the same. That's 1. You can hit pause and try these for yourself if you like, but I'm going to keep going through them. Next, 0.5437 to 3 decimal places, that's where this 3 is, in the thousandths position, and there's a 7 next to it. 7 is bigger than 5, so we'll round up. Next to 2 decimal places, that's where this 4 is. A 4 with a 3 next to it is not going to round up, that's going to stay a 4, 0.54. Next to 1 decimal place, that's where this 5 is. It has a 4 next to it, that's not more than 5, so we'll leave it as it was. And finally, to a whole number, right now the units position has a 0 in it, but we have a 5 next to that, so that 5 is going to make that 0 round up to 1. Next, question D, rounding to 3 decimal places. In the third decimal place, in the thousandths position, we have a 4. With a 2 next to it, that 4 is not going to change, so that's going to be 1.964. Next to 2 decimal places, again looking at my original value, in the second decimal place, there's a 6 in the hundredths position, and that 6 has a 4 next to it, so it will not round up, 1.96. Next to 1 decimal place, in the first decimal place, that's the tenths position, I have a 9 with a 6 next to it. That means that 9 is going to round up because 6 is more than 5. But what is 1 more than 9? 10. How am I going to fit 2 digits in a single place value? Well, this is an exception where that 9 needs to round up to 10. That leaves a 0 in this place value, and we pass that extra 1 up to the units position. So that makes this 2.0. Once again, that 0 there is necessary because I'm rounding to 1 decimal place. I need to show that I didn't accidentally round to 0 decimal places, leaving this just as 2. I rounded to the tenths position, but that tenths position was a 9, which became a 0, passing up the 1. Next, rounding to a whole number, that's where this 1 is. With 0 decimal places, I have a 9 next to it. Before I get rid of all of those decimal places, I'm going to round up to 2. Again, notice these two values are the same value. However, this is a whole number with no decimal places, and this is a whole number with 1 decimal place. Next, to 3 decimal places, it doesn't matter how big the whole number part of this value is. 3 decimal place is in 1, 2, 3 places after the decimal, always the thousandths position. Here we have a 3 with a 7 next to it. That 7 is going to make the 3 round up to a 4. So we've got 70.484, or 70 and 484 thousandths. To 2 decimal places, back to the original again, I've got an 8 in the second decimal place with a 3 after it. That's not big enough to round it up. So that's going to be 70.48, or 70 and 48 hundredths. To 1 decimal place, I've got a 4 in the first decimal place with an 8 after it. So that 4 is going to round up. That will be 70.5. Lastly, to the nearest whole number, be very careful. Never round a number that's already been rounded. That's going to cause an even bigger rounding error than you need. Always go back to the original value, to the nearest whole number. In the units position, I have a 0, and next to that units position, I have a 4. Not a 5, a 4. 4 is not big enough to round up that 0, so that's going to stay a whole number of 70. You see the mistake you would have made had you rounded this number to a whole number? Be careful about that. Now, all of our answers are correctly rounded. However, they are not perfectly accurate. Every time we round, we make a small rounding error. How far off is this number from its original value? The rounding error we made would be 5 tens of thousands. As you see, we make a rounding error every time we round the number. However, when we round to the thousandths position, our rounding error is going to be much smaller than if we round to the hundredths position, tenths position, or the whole number. The rounding error is always much smaller the fewer digits we're knocking off of the number. So here are your rounding errors for each of these answers. Notice that in the 3 decimal places column, our errors are much smaller. In the whole number column, our errors are much bigger. And notice that sometimes the error is exactly the same, like for these 2 numbers, for example. Because these 2 numbers have the same value, the rounding error that we made is the same rounding error, the same inaccuracy. Same thing with our answers down here. They have the same value when we rounded them. Even though I'm rounding to the 1 decimal place or to the whole number, they're the same number. So the rounding error we're making or the inaccuracy we're making is the same. Time for you to practice for yourself. So hit pause, and when you're ready, hit play and the answers will come up. I hope you've had a chance to hit pause because here come your answers. For 3 decimal places, for 2 decimal places, for 1 decimal place, and to the nearest whole number. Now I hope you found this lesson and these exercises helpful. If there's anything that I've left a little bit unclear, please leave me a comment down in the comment section so I can clarify that for you. Otherwise, keep practicing and I'll see you next time.